So guys, as always, we first go through the things which we have learned so far. Um, so I believe we first start with has defined, right? And
Yes, totally.
yeah, so can you help me to define the topics which we learned so far?
First one is like has defines, and like then we gone through this pointers,
Okay.
constructors.
Yeah.
So last class is like types of constructors. We are working on copy constructor. It is finished. Then we move
Exactly.
to pointers.
Yeah.
So now today like we planned for a r- like uh, like real time usage on those things.
Yeah. And we at on last class we learned about vector, right? If you remember.
Yeah. Vector array and vector types, right?
Hmm. Yeah, we learned vector and why we use it, right?
Yes.
Use it over arrays, correct?
Yeah,
So if you remember in vector, right, we have a kind of syntax like this. You remember,
yeah,
right? And I told this syntax is for template, right?
yeah. Today
So
you're gonna say like about the template class.
exactly, that's right. Usually, right, the template topic will come at the end of the C++ course, as many instructors will do. But I don't think I should put it in last, because if we learn about vector with this syntax, then in next section, in today, right, it's better if you learn this, so that will be easy for you to follow up with those ideas. Okay. So today we see about template class and why we need it, and what is the use case of that. So before learning the class, before learning the templates, I will give you one example why we need templates. For that, let me open a Visual Studio. Guys, you have installed compiler, right? Are you practicing daily? Or
Like who you're asking that, Rahul?
both?
So I was like already practicing things.
That's great. Okay. And what about Shiva? Sorry, Shankar?
Yeah,
Ah, okay.
he's in
He's in the office,
office.
it seems.
Yeah.
Okay. But Shankar, you can follow my class, right? Or that's great, man. Okay.
Yeah, Navya. CPP
So this
class
is the example which we
నడుస్తుంది
learned
నవ్య.
last day, right? With a vector, we had created an object.
Ah,
Okay. Then we had a for loop that
okay.
populates the vector, and we store it in an vector field here. Then we have a again for loop for printing the vector, right? So this is the program which we see last time. So the today's class is about what the this syntax means. Okay. So let me clear out this. Now I'm not going to use C++. I'm just going to use a normal function syntax. I'm going to create a function for adding two numbers. Okay, int a and int b. Then, okay, my mouse is slow. Just a second. Yeah. So let me have a main program that calls our function. function add. Okay, I'm just adding 1 and 2. Then
Rahul, can you maximize,
yeah,
like, contents looks small. Can you maximize the
uh
content if possible?
yeah, yeah, yeah.
Yeah.
Yes, yes, it's possible, I believe.
Yeah.
Zoom.
Yeah, now fine.
Okay, right?
Yeah,
Okay,
yes.
yeah, that's great. So I just have a function that will just add two numbers and it will return it. Okay, so let me see out it. This in see out needs a namespace std. Let me define it here. The scope td dot dot. Okay, so let me run that, compile this program. Okay, before that I'm going to locate this file, c++ demo session, I believe. What is this file? Access class that is located. Okay, c++ underscore demo. Fine. cd c++ demo. Yeah. Then I'm going to compile my program with g++ and typing my file name, scrippy, compiling it. Yeah. So let me run it. If I run, I am printing 3, right? So now, let's say I am building a calculator application. Okay. So I don't want this. I mean, this function will just add an two integer numbers, right? What if I want to float? How can I modify it?
We can change the return type to float, or else
Exactly.
we can static cast the result.
You want static as a result?
If we want a integer to be like returned as float, we can either change the function return type if there is
Okay.
no further change requirement with the integer, or else if the requirement further needed as int, we can static cast the result into some with the which other data type we needed.
Okay, but the parameter which I am passing, right? But this is received by an integer type.
Yes,
So,
yes.
so do you want to make it as a float?
Yeah, like if the function return type is changing, then we need to change the parameters as well.
Okay.
If we are using a static cast at the end of function call, there is no need of changing all these. Directly we can static cast into the float.
Where do you use static cast?
At the C outline line number 18.
Okay, so you want me to use something like static cast, something like this?
Static cast, like the syntax is not exactly like we can change it to like in the vector
Okay.
syntax like that we can write float and then the function name.
Yeah, fine. But do you think if I pass like 1.1 comma and 2.4, so do you think this works?
No, it won't work. It will work for one variable only.
Yeah. So anyway, it worked for only one variable. Even though I did a static cast, still I have to modify these parameters, right?
Yes, yes,
And I have to modify this integer type,
yes.
right? So this function is not capable of doing a float values, right? Even though you pass a float, it converts. The implicit conversion is make it as they'll make it as integer. So for example, let's say I'm passing 1.1 and 2.4, right? Um, if I compile it, if I run it, do you see this? It posting an integer value,
Yes,
right?
yes.
It don't know, it cannot operate this even though you are passing float. By implicit type conversion will make it as an integer. So what I will do, if I modify this function, right, then I will lost the functionality of integer, right?
Yeah.
Then one way is doing a separate function, right? Dedicated function
Yeah.
that handles integer as well as float.
Yes. Yes.
So that is one way. Sorry, my
The other
system
way, we
is.
can write a template class with like unknown data type, which we can give
Mm,
any data type.
that's right. Yeah. So if you give a float like this, then as you told, okay, this can let me take as a function float, and even I can if I compile it and run it, so it prints the exactly float value, right? So in future, what if I want to add a double, a type of double, right? The size is more than a float, so we cannot use the same function for the double variables, right? Then we have to create another function. So like that, we can. It's not feasible to create an each and the same function, the same operation, but a different data types, right? So it is not feasible to write a separate function for all those things like double, and in case for if I'm using some character, I'm trying to add two characters right together and return it. I have to pass a separate function like this. So in real time, anyway, it's doing the same operation, right? Just adding it and returning it. So so instead of this, right, we can use a template class. So the syntax will be something like template, and yeah, type name, kind of this. Okay. So here, the syntax for template is we have this is a keyword in C++. Template is a keyword, and a type name is a keyword, and T is a template. Okay. So the T is capable of receiving any arguments, any data type. Okay, not any arguments. It is capable of receiving any data type. Okay. So after the syntax, right, the return type is T now. Okay, because we don't know, we can return integer or float or double. We don't know the return type. Okay, so we have a T here, and return type we are mentioning T instead of integer, character, or float. The function name is same. So we are going to have a two parameters, right, that can be of any type, integer or character or float. So that's why we have a T and T here, right? So now if you call this with a float value, and if you try to compile it, so it returns a float value. Okay. If you pass an integer here, it takes an integer value. Even you can pass a character, so it prints an some garbage value because maybe it is out of an ASCII table, so that's why it is printing some garbage value. But yeah, so the real concept is like we have only one function, right, that performs multiple operations, right? It can add a integer or a float or any data type.
You can tie like without giving those columns once. I think it might work.
Sorry.
For the for the current example for A
Yep.
and B, so
Mm-hmm.
you can try removing those inverted commas, right? Those two are the edit.
Inverted commas at line number 16 you were telling.
16 in the
Yeah.
parameters, you can simply give A comma B and try like that one. Without
You
those, yeah, A comma B. That's simple. Yeah.
like this,
Yeah. Can you run it?
but okay.
Okay.
Because A is not declared yet, right?
Yes, yes, yes.
Yeah. Maybe you're trying to tell something else.
No, actually, like you said, like it is out of ASCII scope. Maybe like A has, if you give separately, it will give the ASCII value, right?
Oh, okay, okay. No.
Uh,
Okay, okay. To print ASCII value, right? You have to do something
yeah.
like this. In C out, if you print A, then it prints out an ASCII value kind of this. Let's say, okay, my compiler sometimes hangs. So due to the WhatsApp, right, it takes a huge media space in my system. Uh, yeah, if you compile it right, and if you print, it prints an okay, it prints an equivalent ASCII value. No,
No, like if you remove the inverted like those braces above, I think it will print those values. It treated as a like a value, and then
okay. Or else, let me try with this again instead of this, right? Uh, ASCII. Let me try to print an integer value from character A. I guess it should compile since it's an part of, yeah. The syntax I am specifically putting an D, trying to print an decimal from an ASCII, I mean from a character, and equivalent ASCII value is printed. Let me try it with C out. What you told, Mahesh?
without those upper squares are there, right? What we say like double
Uh,
quotes, like single quotes.
okay.
You can see out and then just A.
No, it still won't work, I believe, because it's not defined anywhere.
Okay, okay.
Yeah, maybe it should have some way of printing it. Maybe you can use something like test ASCII. Yeah, Shankar.
I think he's saying about typecasting.
Yeah, sorry.
Yeah, this is correct.
Okay, okay, okay. Yeah,
Yeah.
Shankar, got it. Yeah. Yeah, yeah. So the typecasting did it. Yeah. Uh, yes. All right. And this is the way of printing and the template concept. So now this template is right. It is out of we don't. It is not a part of class, right? It is a, we are just having an example function where we have a template. And what if I want to create a template for a class, right? So normally we will define class something like this, class called test. Let's say we have I will define a constructor here, test integer a comma integer b, and let's say I have a two private variable called int x and int z. Okay, so I am receiving this in a parameter. Let me use an initializer list. It's not needed here, but still I think uh, sorry. So initialize list is not needed here, but we will try to in this way so that you can remember the syntax, right? And I will have one function called display, so that would print out the x and z values which get initialized via constructor. I'm missing something, I believe. Okay, close brace. So I have a simple class called a test. Okay, I have a two private variables called int x and int z, and in public section I have a constructor that takes two parameters. Okay, so once I pass a value to constructor, the a will be copied into x and b will be copied into z. Okay, and I am printing x and z. Okay, so I can do something like this. To create an object, you will say class name, sorry, class name and object, and I will passing a two parameters, right? And I am calling a display function. So let me compile it. It should work as you guys expected. X is 10 and z z is 50, right? So here, let's say I want to do the same thing using a template. So how can I do it? Mahesh, Pawan, Shankar.
Like I never used that.
All right.
Having no
It's
idea of
the,
some.
yeah, it's the same thing. The syntax is literally a same thing which we use for a function. You just have to define above the class. Its syntax is template followed by a type name followed by t, right? So in place of integer, this one, right, I am replacing a type as t. So x can be of any type. It can be integer, character, or float. I am putting t here. Same way, this can be t, and this constructor is using a integer. I don't need integer here because I can pass any type of data. So I should be having a t here, right? Then when displaying I am printing and displaying x and z. Okay, it's almost the same thing. And the same way I'm passing an object. Okay, I don't know how it get added up. Okay, so let me compile it. Yeah, it does compiled. And if I run it, it still runs fine. So the thing is here, even I can pass of type 10.5 or 50.7, something like that. If I compile it and run it, it still works. So now this class which I have, right, it is capable of having any type, and also this template deduction will happen at compile time. Okay, during compilation, the compiler will find the data here, right? Depends on the data, the type get assigned here. So this is a syntax for a template. If you want to keep it for a class, this is how it should look like. Let's say here I am passing an to float, right? So the both thing can be replaced by float and float, right? What if I want to pass something like this? Parameter x I will be passing a float, but parameter z, right, I will be passing a character, something like this. So do you think this template works?
No, I guess
Okay, why?
because template is like generic class, like where it is expecting the similar type of parameters for both.
Okay, so what if but I want to use a different one. For x I want to use an float, but for z I want to use an character. uh, do you think it's not possible?
Exactly, I'm not sure about that idea.
Okay, um, so Shankar is telling it will work. All right, so do you want me to compile?
Hmm?
No,
Indra?
it does not even compile.
సరిపోలే.
So here it's telling an error, telling the argument detection failed, right? And no matching function call for character. So for this problem, right, we can do one thing. How about adding in another type here, type name called u, and here instead of t, I'll be replacing a u here, and for p, I'm using a u here. How about using like this, right? So right now, let me compile it. Even I'm not sure this will compile. Let me compile it. Yeah, it does compile. So here right now we have a 10.5 that's of type float, and it sits on a template t. And second parameter we are passing a character that's of type character. So that type will be detected during a compile time and sits on u. So now the compiler knows a t is a float, and a u is a character type. According to it, I am replacing my template here, right? T as x and u as z. Okay, in constructor I am passing a I am changing a template name t and u, and I'm assigning the respective data. Okay, then I am printing the x and z. Okay, let me run it since I have compiled it. Yeah, it does work. So if you want to add an a data like this, the template class, you can pass it is you can even pass a multiple type names here. It is not necessary that the template should be a same data type. Okay, a template can be a different data type also, and the respective uh,
Uh, can we give the type name like anything after that template? Like in here first you gave type name T, right? So
yeah.
after that you gave type name U. So
Hmm.
instead of U, can I replace anything?
Yeah, it's your choice.
Okay, okay, understood.
You can even have Mahesh also. It's not a problem.
Okay,
But
understood,
you
understood.
have to replace it here with Magesh. That's it.
Okay, got it. So it's
Yeah,
like kind of creating an object, kind of, right? So we are creating type a new type.
yeah, correct.
Okay.
That's it. Yep, and this is how the template works. I think now you understand why we have an vector have a template, right? Actually, this syntax is right. When you calling this function, right, you can the compiler will explicitly pass something like this actually. Okay, if you still compile this, right, vector. Okay, sorry. Let me comment out this. Actually, the traditional way of uh, having a template, right, you have to pause like this. Then only the people who are reading the code, right, they can understand that it is a template. Okay, better you can use like this instead of by default the compiler will detect it even though you didn't mention this. But sorry, you didn't mention this the template syntax. But it's good that if you mention this, that clearly tells the users that this object is a template, this class is a template, you can pass any type. Okay, so it's a good idea, I mean it's a good way of using like this. Okay, I think now you can understand why you guys can tell why the vector is using an
హ్మ్.
syntax like this.
షెడ్యూల్ ఇప్పుడు అయిపోయిన తర్వాత స్నానం చేయాలి.
Yeah,
స్నానం
Rahul,
చేసి
understood.
You
బ్రేక్‌ఫాస్ట్
understand, right?
చేయాలి. చేసిన
Yes, yes.
తర్వాత
See,
సమ్
uh,
కంటెంట్ హావ్ టు మేక్ టు
a
స్టార్ట్
vector is a class
డిస్కషన్స్.
actually. Okay, that class is a template class.
తర్వాత 4 key
The
class
vector I can
ఉంది.
pass an integer like this, or the same class I can pass a float, and I can give a float data like this. The same class I can pass an character. So all the data type it is adapting, right? The same syntax will adapt. So the thing is, the vector is a template class, something like this, which we defined here. I think we can go into the class. Let me go into the vector class. See the top, right? This class is from std namespace, and this class, if you see above, right, it is a template class that can receive any data type. And according to that, this syntax, I'm really not sure. Only God knows this syntax. I don't know, but there are a lot of things going on here. But the high level, if you say like this is a vector class, this is a template class,
Understood, sir.
and yeah, so this is how it works, and that's why we have template usage everywhere. Even the all the std templates will have a, I mean, std libraries will have a template class, something like this. And one more thing I thought of telling about templates. uh, mm, mm, mm. Okay, so tomorrow, right, I want you guys to spend some time on template. I guess it's template specialization, I believe. Let me check that name. Template template specialization or tokenization. Yeah, yeah, yeah. Can you go to this topic, and can you explain in next class how this works? I can put it in chat box.
Yeah, okay. I will go through that.
Yeah, sure. I think this we'll learn this, right. If you are good in templates, right, then you can master C++ much more easier. The many people will deny to use a template actually. If you're reading good in reading the template, right, the template code, then you can even you have even cracked the almost the complex topic in C++. So template is a very important one. And what else we can learn about templates? So any doubts apart until now?
No, Rahul.
Okay.
So this template specialization C++, this is Microsoft Learn, that one only, right?
Sorry.
So you shared the link. Actually, I logged in today in my mobile, so I can't directly check the message there.
Okay.
So, so this template specialization C++ is a Microsoft build, right? So you're saying I need to check today.
No, not today. Tomorrow. Actually, there's a concept called template specialization.
Yeah, can you open that once? Like I just confused, like whether I'm opening the correct link.
Okay, okay. Yeah, this topic.
Okay, got it.
Yeah, yeah, yeah. So this topic have a different syntax. And tell me about what is the difference between a template specialization and this one, the syntax which we use here. This is just a, this we normally in C plus we call a template class, but the template specialization is a kind of this, but a different concept. But it works same as this. Maybe if it's good if you tell me the difference between this and that.
Maybe in the next class we'll try to
Next,
tell you.
yeah, yeah, next class, yeah. Yeah, I think for templates, this much knowledge is enough. I think to start with templates and future ones. So if you see any C++, right? Are you aware of smart pointers?
Yeah, Rahul.
That's great. Even smart pointers, you'll be having a template actually. Let's say for a shared pointer,
Yeah, STD make shared.
make shared. Yeah, shared pointer. Sorry. Okay, this intelligence is adding a more code. See, if you see this right, it's a template class. If you see any syntax like this, then that means the shared pointer is a class that is of template class. If you go inside a shared pointer, you can see a template above. So
Yeah.
wherever you see that Angular basis, right, everything is a template class. You can pass any data type in that.
Okay.
Yeah. Uh, yeah. Actually, today we end with this since I have one personal work. Sorry, guys. Maybe tomorrow I will continue with some more topics. Tomorrow we will first. You guys let me know about the template specialization, okay? And I will continue some new topics. I think we can. I think now we can go to go through on smart pointers tomorrow. So after that, we will go for this inheritance concepts. Okay.
Yeah. Okay. Sure.
Yeah. Any doubts, guys? So today shall we end today little more earlier today now?
Yeah. Okay.
All right. Okay. Anvesh, this is recorded, right?
Yes, yes,
This
Rahul.
session.
Yep.
Yeah, that's great, Anvesh. Yeah, I
Yeah.
think Pawan joined late. Maybe you can share with Pawan also.
Yes, yes.
Maybe.
Like I will inform to everyone whoever registered, no, like their dashboard they can see the recorded video. I will try to post in our YouTube channel also.
That's
When
great. Okay.
yeah,
Pawan, please let me know if you have any doubts. In case if you missed any concepts.